it comes to fall protection, we have two priorities in fall protection. Our first priority is real basic and real simple, and that's to keep you guys from falling in the first place, which is obvious. There's a checklist of things we always want to think about doing before we start relying on using harnesses and lanyards. This stuff back here is your last resort. It really is. The best thing, so there's a checklist of things we want to think about doing, and the best thing we can do is bring the work down to ground level. If it's at all possible, bring the work down here, which is obvious, but unfortunately we oftentimes or usually cannot do that. So the next best thing we can do is put up a guardrail system. We can either put up a permanent guardrail around like a mezzanine in a plant or a catwalk or something like that. We can easily put up temporary portable guardrail systems around the edge of a roof or something along those lines. And also, by the way, using guardrail includes scaffolding, scissor lifts, JLGs, articulating aerial lifts. You always want to try to use one of those if at all possible. And I know you guys all know this, but I got to go through it anyway because it's important. And then the third best thing we can do, if we can't put up a guardrail system of some sort, the third best thing we can do is something we call fall restraint. If we can't put up a guardrail system of some sort and we can't use fall restraint, now we have to start thinking about using a fall arrest system. A fall arrest system is a full body harness, a shock absorbing lanyard, and your anchor. Those three things working together make a fall arrest system. Anytime you're working at heights of typically 6 feet or more above the ground or the next lower level, and you have the potential for a fall, you must use a fall arrest system. This truck behind me is basically an impact machine. What we're going to do is we're going to cover the basics on hooks, lanyards, harnesses, how to properly tie off. When we're done covering all that stuff, we're going to start dropping Bubba here. Bubba's my 220-pound weight. We're going to take him up in the air. We're going to drop him with a couple of different lanyards. We're going to see how many pounds of impact he generates in that fall, and we're going to reduce that number by dropping him for a second time with a shock absorbing lanyard to show you how, how one of those rips and how it absorbs impact and protects your body. So that's what we're going to cover. If you have any questions as I'm going along, please fire away with the question whenever it comes to you, all right? We no longer use these, and the reason why is, like I just said, the gate is not self-locking. The problem with this type of hook is, if you got twisted around on your lanyard just right, all it would take is a little bit of tension on your lanyard, like from my pinky here, and you could have rollout. That's why we don't use single action style snap hooks any longer. Now, we've got to use a 2-action style hook, a hook that takes 2 separate and independent actions to open, like so. But more importantly, the gate is self-locking and self-closing. So now if I get twisted around, I'm less likely to have rollout because I'm using a self-locking, self-closing style of hook. They come in all different shapes and sizes, but they must take 2 actions to open, and they must be self-locking and self-closing. Real simple. The way we typically comply with 100% tie-off is by using a twin leg or 100% tie-off lanyard. This small hook goes to the back D-ring of my harness. Now I've got a lanyard with 2 legs on it. The idea here is I can be tied off on something over here with this leg of the lanyard staged on my harness, not in use, and I'm working over here. Now let's say I need to move over there and work on something. Remaining tied off with this leg of the lanyard, I take this one, I hook, I unhook, and I move. I can travel from point A to point B, remaining tied off 100% of the time. And the way we typically comply with that is by using a 100% tie-off lanyard. Every lanyard we make is available in this configuration. The reason I bring that up now is, what if you don't have a twin leg lanyard and you're told you got to use 100% tie-off? We see people doing this. Do not do this. That is not a compatible connection. Do not hook 2 single leg lanyards into the back D-ring of your harness, all right? You must use a lanyard designed for that application. Another issue that we see out there is, let's say you've got your harness on and you've got your lanyard attached to it and you want to use a self-retracting lifeline. We see a lot of people wanting to do this thing. They hook this into this like so. Do not do this. Never hook a hook to a hook, or a hook to a carabiner to a hook, or anything like that. And the reason for that is, it's possible for one of these hooks to rest on the gate of the other hook. If you were to take a fall now, that hook very likely could blow that gate out and you'd end up taking a fall. It's called cross-gate loading of the hook. It's a huge problem in fall protection, and we'll discuss it in much more detail here in a couple of minutes. But for now, remember, never hook a hook to a hook. If you're using a self-retracting lifeline, this hook goes directly to the back D-ring of your harness. Do not add one of these things between you and the retractor. A lot of people don't realize it, but this is obviously an energy absorber. Everybody knows that thing, that rips to absorb energy, right? Well, self-retracting lifelines are energy absorbers. The way they work is as you walk down, it pays out. As you walk up, it pays in. If you slip and fall, once you get moving about 3.5 feet per second, it's going to lock up on you. After it locks up on you, it will let you out a little further as it absorbs impact. Our first one has to do with our lanyard. Here's a question for you. What's the maximum length of lanyard OSHA allows you to use for fall protection? Who knows? Everybody agree with that? 6 feet? Guess what? You're wrong. OSHA could care less how long your lanyard is. OSHA doesn't say a word about length of lanyard. Well, they're designed to withstand the forces of a 6 foot or less fall, which is why in fall protection we always teach people with your typically 6 foot or shorter lanyard, you always want to tie off at least shoulder height or higher. Okay? It just makes sense. If you're tying off back D-ring height or higher, you're never going to go over the 6 foot free fall rule, right? So you always want to tie off as high above your head as you can. You want to take slack out of that lanyard so you have less free fall, which means less impact to your body.
Don't you usually try, are you supposed to try to tie off as close to directly above you as possible?
Yes. Yeah, you're exactly. Yeah, you do want to do that, especially when using a self-retracting lifeline. Because if I'm tied off to one of these things and I come out here and I fall, what's going to happen to me? I'm going to swing, right? Yep. That thing's going to lock up on me. It's going to stay locked up as I go swinging through all that stuff. So you're exactly right. You always want to try to tie. 6 foot lanyards is not as big of an issue because your swing is only going to be 6 feet, right? We have all kinds of stuff like bolt-on or weld-on D-rings. Drill a couple of holes, bolt it on, leave it there. Probably not good for what you guys do for a living, but for plant maintenance and things of that nature, excellent anchor point. Install it, hang a retractable like I've got up here, put a tagline on it. You've always got fall protection for whatever you're working on in that area. Similar, but for concrete. If you got a concrete column or wall, drill a hole in it, thread this expansion bolt. When you get to the right foot-pounds of torque, it'll shear the red bolt head off, exposing a green bolt head underneath it. Red, it's not an acceptable anchor. Green, you're good to go. Okay, because you have to, it's got to be torqued in the wall with the right amount of torque. I'll pass it around. You'll be able to see the green bolt head underneath the red one. That can be a permanent or temporary anchor. If you take it out of the wall, you got to buy another expansion bolt, put it in the D-ring, and reuse it. This is a temporary concrete anchor as well. Drill a hole in a concrete column or wall, pull the trigger, stick it in the hole. You wind up with a D-ring you can tie into. When you're done, pull the trigger. You might have to tap this sleeve with the tool, pull it out of the wall. Very simple. We have all kinds of things for I-beams. This is called a fixed beam clamp. You've probably seen them. Pull the pin, slide the jaw into the flange of an I-beam, pin it back in, crank it down until it's tight on that I-beam, and what you wind up with is a rotating D-ring you can tie into. Fixed beam clamps can be used on horizontal I-beams as well as vertical columns. These can be used on columns. If you take a fall, it's made to go on a